Hey, this is Mr. Word. I'm going to do a key for today's Do Now. I'm calling this day week 17, day 2, because we only got 2 days of geometry for geometry this week. So here we go. So first, prove it. Reminders, what does a bisector do to a segment, and what are vertical angles? So just reminders. When I write those reminders, they might be in the proof. So given that PK and JM bisect each other at R. So this is PK and this is JM. So PK bisects JM. So we can now add information there. And we can add some information here because of that. I'll come back to that in a second. And we're supposed to prove that PJ and MK are congruent. So this is PJ. I'll roughly mark the things that we're trying to prove are congruent. It's useful to keep that in mind. Now, let's think about what we need in order to prove that these two are congruent. It would be useful if we could prove that this triangle and this triangle are congruent, two triangles that contain PJ and MK. So if we can do that, then I think we can prove these two triangles are congruent. So after the given, there's really only one given. What we can say is that PR is congruent to KR, and we can also say that JR is congruent to MR by definition of bisection. Okay, now that we've proven that, we can go on to make note of the fact that angle 3 and angle 4 are congruent. So let's label them as congruent. So there we go, angle 3 and angle 4. We can declare that they are congruent. And the reason we can make the statement that they are congruent is because they're vertical angles. Definition, that's the vertical angle theorem. So angle 3 is congruent to angle 4 by vertical angles theorem. Okay, and now once we have that information, now we have an information to declare these two triangles are congruent. So we can say PR triangle, PRJ, that's this one, PRJ is congruent to triangle, now we have to name it in the right way, KRM, because K is corresponding to P because we're heading along the congruent side. And these triangles are flipped here, where it's like a twisted bow tie. So PRJ is congruent to KRM. So triangle KRM by the side, angle, side, posite, side, angle, side, in both cases, side, angle, side postulate. Okay. Once we've proven that, now we can state that PJ and KM are congruent by Kappa-Kadaka. So PJ is congruent to M, so I'm going to call it KM because that actually keeps it labeled along corresponding parts, because M is corresponding to J. I actually object to this order by corresponding parts of congruent triangles are congruent, Kappa-Kadaka. So PJ is congruent to KM by Kappa-Kadaka after we proved that the triangles were congruent by side, angle, side, which required us to show that the angles 3 and 4 were congruent by vertical angles theorem, which required us, separate from that, we also needed for side, angle, side to prove that PR and KR were congruent and JR and MR were congruent because these two segments bisect each other. The fact that it's each other really mattered. Okay, for the next one, you're going to need one of these theorems. So these are theorems from the isosceles triangle theorems section of chapter 3. But you may have heard this or know this already. If two sides of a triangle are congruent, the base angles opposite of them are congruent. And what that means, if I have a triangle, if this side is congruent to this side, then this angle is the angle opposite to it, is congruent to this angle here. And this theorem is reversible. If the base angles of the triangle are congruent, then the sides that are opposite of them are also congruent. So this is a reversible theorem right there. Okay, sometimes theorems are reversible. So here we go. We're going to need, it says we need the addition property here, and you will need one of those theorems, 19 or 20, above. Notice that the overlapping triangles will help as well. Okay, so and I should say that. Okay, so we are trying to prove that Hce is isosceles. Hce is the big overall triangle. And you can see there's lots of there's this triangle here, there's this triangle here, and then there's this little triangle here. Then there's a couple of quadrilaterals. We're not going to worry about the quadrilaterals right now. So let's deal with the givens. DG is congruent to HF. So let's label those things. DG, this here, DG is congruent to JF. So I'll just color code those. Okay, and then we also know that DE is congruent, this is DE, is congruent to JH. And then we also know that EG, here's EG, is congruent to HF. So I'll pick a light blue for that. Okay, so there's EG, and I'll do that. Okay, those two are congruent as well. So we need to prove Hce is isosceles. So let's take a look at what we got. We got a couple of overlapping triangles, and those overlapping triangles are going to give us what we need. Because you might notice they've got 3 congruent sides, and that's going to allow us to prove that these 2 triangles are congruent. If we can prove that, then we'll be able to prove that these 2 angles are congruent. And if we can do that, we can invoke Theorem 20, which says that if the base angles of a triangle, we'll treat, even though this is a side, we'll treat off to the right, we can treat these as base angles. Okay, so here we go. We can say, after the givens, we can then say triangle HJF is congruent to triangle HJF, so EDG. So HJF, EDG, triangle EDG by side postulate. Okay. Once we've proven that, then we can say that angle H and angle E are congruent by Kappa. Corresponding parts of congruent triangles are congruent. So we can go ahead and label those as congruent too. So that's congruent to that. And now we can say that these sides opposite are congruent. So I'll pick purple here for this. So we'll be able to prove that this side, CE, is congruent to CH by Theorem 20. Okay, by Theorem 20, or base angles, actually I say congruent base angles of a triangle mean that the sides opposite them are congruent. And then we can say triangle HCE is isosceles, isosceles, by definition of isosceles. Okay, two congruent sides. Okay, and there you have it. I hope that helped. Please do continue to make sure your proofs are shared with me. If you are done with chapter 3, the chapter 4 stuff is ready for you, and I'll set up breakout rooms as usual.